GATE 2021 Civil Engineering Set 2 Question 55. For a 2-degree curve on a high-speed broad gauge rail section, the maximum sanctioned speed is given as 100 km per hour and the equilibrium speed is given as 80 km per hour. Considering dynamic gauge of broad rail as 1750 mm, the degree of curve is defined as the angle subtended at its center by a 30.5 meter arc. The cant deficiency for the curve needs to be found in mm and should be rounded off to the nearest integer. The relevant NPTEL reference has been cited. Coming to the useful data for this question, we need to find the cant deficiency. Cant deficiency is nothing but the difference of the theoretical superelevation and the actual superelevation of a railway track. For theoretical superelevation, we find it using the maximum speed, and the equation is given as gv square by 127r, where v is vmax. And for finding the actual superelevation, we use the same equation, but here we use the equilibrium speed. For this, speed will be equilibrium speed. G is the gauge length, which should be substituted in meters. V should be substituted in the units of kilometer per hour, as the factor 127 takes care of the conversion. R should be substituted in meters, and the superelevation will be obtained in units of meter. Coming to this question, the maximum speed is given as 100 kilometers per hour. The equilibrium speed has been given as 80 kilometers per hour. And cant deficiency needs to be found, which is given as the difference of theoretical superelevation and the actual superelevation. Theoretical superelevation minus actual superelevation is g vmax square over 127r minus g v square over 127r. Here r is defined for a 30.5 meter curve. We know that if this is an arc whose angle is theta, the length of the arc is L and radius is R. So theta is given as L over R. In this case, theta is 2 degrees, length is 30.5 and radius is R. For conversion, we should use this 2 degrees in radian units. So R will be nothing but 30.5 divided by 2 times degree should be converted to radians using the factor of pi by 180. This would give radius as 873.8 meters. This will be used in the calculation of cant deficiency. So G is 1.75 divided by 127 into 873.8. Vmax is 100 square minus V equilibrium is 80 square. This would give 6300 over 110972.6. This would be around 0.05677. This superelevation or cant deficiency obtained is in units of meter, but the question has instructed us to find it in units of mm. So this value will be multiplied with 10 cube. This would give the answer as 56.77 mm. The question also asks to round it off to the nearest integer, so we can round it off to 57 mm. So The degree of a curve was given for a broad gauge rail section. The maximum speed and the equilibrium speed were given. The gauge length was given and the arc length was given. The Kent deficiency was found out to be 57 millimeters. The relevant NPTEL reference has been cited.